There are two important protocols what you are going to learn in the transport layer protocol, and those protocols we call it as a UDP protocol and a TCP protocol. So sir will be discussing about, let's see, depending upon how the time permits. So for the time being I am starting with this transmission control protocol. For the time being I am starting with this transmission control protocol, and if time permit means I will only complete the UDP protocol and sir will be discussing the rest of the part. Okay. So if you see the observations, that is the transport layer protocol, on what are the protocols we are going to work on this transport layer protocol is basically we work for TCP protocol and the UDP protocol. So as we have discussed so many things about this TCP protocol and the UDP protocol is TCP protocol is nothing but transmission control protocol, and UDP protocol is a user datagram protocol. And we also know that TCP is a connection oriented protocol and it is also called as a reliable protocol, whereas the UDP protocol we call it as a user datagram protocol, and that is a connectionless oriented protocol. So since the TCP is a connection oriented protocol, the transfer, the reliability or the more percentage of data transmission from source to destination is possible, whereas in the case of UDP the successful rate of data transmission from source to destination, it will be very nil. Therefore this TCP is gaining more important mechanisms, or we can say that the TCP is playing more important role for the reliable data transmission between the one process to another process through the use of this transmission control protocol. So in this subsequent sessions we are going to study more details on what we mean by transmission control protocol, what are the services of this transmission control protocol, and how the connection has been established between the source to transmission before we go for this transmission control protocol. And we discuss about how the data frames will be transmitted over this protocol. So all those things we are going to discuss in this protocol. Okay, and the next one is how once the data transmission is successful, we have come up with a successful data transmission from source to destination, then how we are going to use the termination of this data transmission from source to destination, we will be seeing it. Okay, so the first thing is, so let us try to understand, so what are the services this TCP layer protocol will provide us for the data transmission from source to destination in the transport layer protocol. So the first services this TCP is provide is the process to process communication. So as we discussed, so there are different varieties of communication will takes place from source to destination. So one of the communication, what we call it as a process to process communication. Can anybody tell me what you mean by process to process communication? Yes, Shreya. What do you mean by process to process communication, and what do you mean by peer to peer communication? Yes, Deepshi. See, as I said you, the network layer is responsible for host to host communication. So what do you mean by host to host communication is, see, the data transmission from one system to another system, or the data transmission from one node to another node, we call it as a host to host communication. Then what you mean by process to process communication is, see, each node or each computer will be working on different applications, and each application, if for the implementation wise, the application has been divided into architecture, that is objects, and each object works upon some functions, we call it as a process. Okay, so the application where you are running your system or the application, so let's say you have opened a WhatsApp. So WhatsApp is an application. So if the WhatsApp has to work properly means, then the implementation of the WhatsApp has to be done, right? So the implementation or the working of this WhatsApp we will be dividing in terms of process to process. So even though the WhatsApp is a single application, for the implementation wise it will be consisting of a several number of processes. So the several processor will work simultaneously so that your WhatsApp application will be run successfully in your system. So now the network layer, as I told you, it is a data transmission from host to host data communication. So means what, I have transmitted my data and that data has been received at the one destination node or a computer. Now in that computer there are several applications or there are several entities are there. So among this entity, which one where you need to transmit the data, for which process this data has to go, so that will be done by the transport layer protocol. Okay. It's not that if okay my job is to transmit the data from one computer to another computer. Yes, I have done this. That has been already completed in the network layer itself only. But within my system there are so many applications are running, and each application has been divided into processes, and these processes will work upon the data. And if you remember, when we talked about a network transport layer protocol, we talked about a number of ports, that is hardware ports we talked about and the software ports we have talked about. Do you remember these things? I think Shreya, you are asked me, means we had a discussion, the software ports, applications, user-centric ports and application-centric ports. Hmm. So those cases, so when you want to transfer the data or when you want to deliver the data from one process to another process, the port numbers are very plays an important role. So your TCP protocol, it provides the services for the process to process communication by using the port number. The next one, it provides a services by using a stream delivery of packets. Okay, so what do you mean by stream delivery of packets is, so the data will be transmitted in the form of, if you have a large number of data means, then the large number of data will be, or if you have a larger size of data means, then it is not possible for us to handle at a single traffic size means, then what we do is we do the fragmentation. Okay, so when we're doing the fragmentation, it is necessary for us to ensemble the fragmented values so that I will be getting the original data at the destination site. So in order to do the fragmentation process or the fragmentation process to be successful, we use a sequence number. Okay, so by the use of sequence number, we can able to reassemble the fragmented data properly, and it will be reached to the destination with the original form only. So that we call it as a stream delivery services. Okay, so means what, in the stream delivery of services, the once the TCP has been initiated, once the transmission control protocol has been initiated, in the form of streams of packets will be transmitted from source to destination. So you can see in the diagram, this is the one of the simple example which depicts how the data will be transmitting from source to the sender. You can see from the TCP layer, the sending process, once it is initiated, it will be fragmented in the form of frames, and each frames will be converted into packets, and those packets will be transmitted in the form of zeros and ones. That is nothing but a stream of bits will be transmitted from the sender TCP to the receiving TCP. So that is one of the type of services which will be given by the TCP control. That is a TCP protocol. That is a transmission control protocol, and it provides one more important services, as the name itself indicates. It is a connection oriented and it is reliable data services. So it provides services which is our reliable services. Okay, so this since TCP is a reliable transport layer protocol, it uses an acknowledgement mechanism to check whether the packet has been transmitted successfully and it has been reached successfully to the receiver or not, through the use of acknowledgement messages. So in the TCP layer protocol, when I transmit any packet from the transmitter end to receiver end, once the packet has been received at the destination will acknowledge the transmitter saying that this is the packet what I have received successfully without any error. So therefore, we say that the TCP layer protocol, or we say that the TCP protocol provides a reliable communication or provides a reliable data transmission between the source to destination will able to give us. Okay, so that is all about your reliable services. And then it provides services for the full duplex communication. It provides services based upon the full duplex communication. Yes, now can anybody tell me what you mean by full duplex communication? Very good. So in the full duplex mode, bidirectional data transmission is possible. So means what, if I am a node or if I am a computer, I want to transmit the data means I can transmit and receive the data simultaneously. So that type of communication is possible from the use of a TCP protocol. And the next one is it provides a mechanism for the multiplexing and demultiplexing scheme. Okay, so when I want to do the data transmission, so especially in the case of connection oriented protocol, so this multiplexing and demultiplexing will enable us to speed up the execution of data transmission. It not only speed up the execution of data transmission, it also reduces the redundant information transmission from source to destination. And since it is a connection oriented protocol, it provides services based on connection oriented protocol. Okay, so when process, let's say when node A wants to transmit a node C means, then the following three phase process which will takes place. So what are the following three important process will takes place between the data transmission is, the first one is the two TCPs establish a logical connection between them. Even though they are not physically connected, we will make sure that the dedicated path will be present between the transmitter and receiver logically, and once the logical link it has been established between the source and destination, then what we do is we do the exchange of data in both the direction. So once the exchange of data in both the direction it has been completed successfully, the next thing what we do is we going to terminate the link which has been created for the data transmission between the source and destination. So these are the services or which has been provided by the TCP protocol. TCP is a transmission control protocol. Transmission control protocol. So what are the services it is providing? It is providing process to process communication, stream delivery services it is providing, reliable services it is providing, full duplex communication, multiplexing and demultiplexing, and then it is providing a connection oriented services it is providing. Then, so next, what are the features of this TCP is having? So what are the features of this TCP having is, it is having one of the important feature is, that is the numbering system it is having. So why we are going to use this numbering system is, so when we want to do the segmentation of the package, or when we want to do the segmentation of the stream of data which is coming from the application layer, then we are going to use a segmenting number. So that numbering the packets or the giving the numbering values for the data which is coming from the upper layer, we call it as a numbering system. And this numbering system, it has got two important fields in the segment number. The first one we call it as a byte number. Okay, the first one we call it as a byte number. So what do you mean by this byte number is, so it is a TCP number for all the bytes that the transmission it takes place during the connection mode. Okay, and this byte number it is independent for the each direction. So means is, since I told you the TCP is responsible for two-way connection, or it is a full duplex mode of communication from source to destination, so the numbering has to be unique for each direction. Therefore the numbering is independent of the direction. When TCP receives the byte of data from the process, the TCP source stores them in a sending buffer and number them. So when and during the at the transmitter end, so when it receives a data which has to be processed or it has to be transmitted, means then that data will be stored in a sending buffer, and for that number we are going to give the numbering value for the identification. Okay, and it is not necessary that always the numbering has to start with a 0 only. Okay, and one more important thing what we are going to do is we are going to use a sequence number. So as I told you, this sequence number will be responsible for us to do the segmentation. So when I do the segmentation, let's say you have a 3 MB of data, and this 3 MB of data, it is not possible for you to transmit simultaneously at a stretch, means then what we do is we use a sequence number. So if the 3 MB of data, if we divide it into 1 MB, 1 MB, 1 MB, like a 3 different smaller packets, means then for these packets we need to give the number values, and those number value we call it as a sequence number. Okay, so the sequence number, it is responsible for us to do the assembly, reassembly of the packets at the receiver, so that whatever the division we have incorporated at the transmitter side, so it has to be clearly do the reverse process of the assembly. So when you want to do the assembly, you should make sure that the original data, that is the transmitted data, should decode it at the receiver side. So therefore the sequence number plays an important role in reassembly of the data, so that we are going to get the original data at the receiver side. So there we are going to use this sequence number. Okay, and then how we are going to use this sequence number, it has been given in this diagram. You can see here, suppose a TCP connection is transferring a file of 5000 bytes is there. So for the first byte, it is numbered as 1001. What are the sequence number for each segment if data are sent via 5 segments? So now you can see here, so for each 1001 byte, we call it as one sequence number. We will be allocating one sequence number, and there are 5 segments are there. So therefore, since you need to transfer a 5 kilobyte of data, that is a 5,000 bytes of data you need to transmit it, and they said that one segment we can hold a maximum of 1001 bytes it can transmit. So therefore you have a 5 segments is there, and for each segments we need to give a sequence number. So you can see how we have allocated the sequence number. So for the first segment 1 it can hold 1001 to 11,000, and then 11,000 to 12,000, from 12,000 to 13,000, and from 13,000 to 14,000, and from 14,000 to 15,000. That is the range what we are giving. And for the sequence number for the segment 1 we are giving 1001, and for the segment number 2 1101, segment number 3 12001, segment 4 13001, and segment 5 14001 we are giving. So this is how we can make use of the sequence number when we want to do the fragmentation of the data, that is in terms of smaller packet size. If you want to transmit means, then we are going to use this sequence number for the data transmission.